Good afternoon, guys. This is Mr. Varela, and this is week number 4 of 8th grade distance learning. If you're in 7th grade, you may want to shut off the video because you were doing evolution of living things. There is videos they have to watch, and there's a quiz at the end. For my 8th graders, though, you guys are doing these worksheets, and the videos kind of explain how to do the worksheets, but I want to go over individual problems. If you hear any background noise, I'm actually doing this video outside. It's a nice day today, so if you hear the occasional bird chirping or airplane flying by, or I live next to a golf course, if you hear the occasional, golfer yell, it's because I'm outside, okay? Hopefully my papers don't fly like earlier. Okay, so just like last week, there are handouts that you need to print. If you do not have a printer, that's fine, but you're going to have to get a blank sheet of paper like so, and you're going to have to basically write down the problems on a blank piece of paper. Some of you did that last week and it was great. There was no problems at all. You guys copied down the questions and then put the answers, took a picture of it, and then submitted it. There's been some questions online about, do you want the work submitted through Google Classroom or through my email? If you read the instructions, it clearly says, please submit the work by email, and I put my email address. Now, I am accepting documents through Google Classroom, but please, I don't want to hear a complaint, well, I'm having trouble with Google Classroom. That's why I don't want you to use Google Classroom. There have been 0 problems with students sending work through email, but there have been many problems about documents uploading properly in Google Classroom. So if you choose to submit your document through Google Classroom, that's fine, but you picked your poison. I recommended to use email. So far, email has been 100% reliable. Okay, let's get started. One of the handouts that you do not have to print out actually is this one, the periodic table elements. Now, this one is different than the one that I gave you guys last week. Okay, the periodic table elements that I gave you guys last week was for something else. I mean, it's still a periodic table, but this one is useful because it shows you the ions. Specifically, it shows you the cations, like the positive lithium or the beryllium with the 2 positive charge, or it shows you the anions like oxide, which is 2 negative, and nitride, which is 3 negative. So you don't have to print this out. While you're doing the handouts, you could have this on your laptop screen or your cell phone. So this particular one doesn't have to be downloaded because you do not have to turn this one in. Now there is this side. It's like a back side. You don't really need this one if you're in honors and you do the worksheet. This is kind of useful. But for the time being, this was included with the handout. This is just the easy way to look up some common ions, some cations right here, some anions, and then we have basically also polyatomic. Poly means multiple. So notice that, for example, right here, hydrogen, it's just hydrogen, right? And here we have rubidium, and here we have sulfur, which is sulfide when it's negative, and iodine, which is iodine, so on. But notice that this one is NH4. It's 1 nitrogen and 4 hydrogen. That makes ammonium. And when it's together, even though it's 5 elements, it's 1 nitrogen and 4 hydrogen, it only forms 1 positive charge. So it's called polyatomic because poly means multiple. You need multiple atoms to make just like a couple of charges. We may get into that in honors later next week. For now, you just need this right here to help you, okay? So what we're going to get started is actually the practice one. This practice problems, you don't have to submit it because, drum roll, I included the answers, okay? You could download the practice problems, and you could download this one. We're going to go over this one to show you basically how to do what's called the crisscross method. Now, before we begin, there is a warm-up, and I just want to go over one way that we could find out the valence electrons and like what kind of ions it forms. I'm going to use, again, like last week, a Sharpie. Please use a pencil for your work. If you use a pen, you may have to use whiteout. The only reason why I'm using a Sharpie is because it comes out better on video. If I use a pen or a pencil, it's really hard to read. Okay. So for this one, it's asking to look up, it's just warm up, look up these 4 elements and write down number of electrons and valence electrons and ions. This is just a review, okay? Hopefully you won't fast forward this part of the video. For potassium, K, if we look it up, potassium is right here. Now, potassium has an atomic number of 19, and that means it has 19 protons. And when it's neutral, it has 19 electrons. Okay? Now, that's when potassium is neutral, not when it's an ion. Okay? If it's got 19, see, atomic number of 19, if it's got 19 positives, it needs to have 19 negatives to balance out. But the number of valence electrons, that's how many electrons on the outer energy shell. Well, the shortcut was look at the group number, the column. Since potassium is in column number 1, that means that it has 1 valence electrons. Okay, so it has 1 valence electron. Now, what kind of ion does it form? Well, is it going to be a positive or it's going to be a negative? What we learned is that when it comes to valence electrons, you want to have a full octet. You want to have a full energy shell. So either you're going to accept electrons to fill up your 8, or what if you have very little? What if you only have 1 or 2? Well, you're a long way to filling it up, so you're most likely going to donate it to someone else. Because potassium only has 1 valence electron, it would need 7 to become a full octet. That's a tall task. It would be much easier for potassium to give up its single electron and to give it to someone that already has 7. That way they can make their 8. So potassium doesn't get its full octet, doesn't become rich in valence electrons, but it helps its friend become rich in valence electrons. And remember what I said, the next best thing to winning the lottery is your best friend winning the lottery, because it might not be your money, but now you get to tag along. If potassium helps someone else get rich, someone else, for example, that's in this column right here, that's going to be great. So it's going to give up this valence electron, and when you lose an electron, it actually forms a negative ion. Okay? I'm sorry, it forms a positive. See, it's a little confusing. It took me a little while to remember that. Here's why. Let me get this paper. Let me show you. Remember, whenever you lose something, it's negative. You lose $5, you have $5 less in your bank account. Okay? Now, electrons are also negative. Okay? So if you lose an electron, it's actually positive. Remember, in algebra, a negative times a negative is equal to a positive. So whenever you lose an electron, it's actually a positive sign. You become a positive ion or a cation. So in this example, whenever you lose a valence electron, you're going to form a 1 positive charge. Now, lucky for us, this periodic table actually has that information for us. It shows you right here for potassium, it's got a positive charge. Okay? Now let's look for iodine. Iodine is right here. Okay? It says iodide because it's already as an ion, but when it's neutral, when it's not a positive or negative, it's called iodine. And it's got an atomic number of 53. So if it has 53 positives, it has to have 53 electrons. I mean, that's a lot of electrons. Okay? But how many of those 53 how many of those 53 electrons are valence electrons? Well, let's look at which column it is, okay? If we look down, iodine is in column number 17. According to the shortcut, it's got 7. Remember, it goes column 1 is 1, column 2 is 2. We skip the transition metals. 13, column number 13 is 3, 14 is 4, 15 is 5, 16 is 6, column 17 is 7. So iodine, out of the 53 electrons, 7 are valence electrons. Okay? So, is it going to form a positive or negative? Well, if you have 7 valence electrons and you're that close to getting an octet, you are more likely going to take someone's electron rather than donate all of yours. You're so close to being rich with 8 valence electrons. So what's going to happen is someone like potassium, who has 1 valence electron, is going to donate to this guy. Potassium is going to help his BFF iodine have a full octet. So now iodine, when it takes that electron, now iodine has 8 valence electrons. It's rich. Potassium lost that its only valence electron, but because it helped his friend iodine, when you get something like potassium iodide, which is basically potassium sharing or giving up its valence electrons to iodine, it helped his friend become rich. Now, whenever you get negatives, when you become more negative, you form a negative ion, because the more negative you get, the more negatives you get here. So the more negative electrons you get, the more negative you come here. And we can verify our answer. Iodine was a negative. Okay, let's do the next two. Phosphorus. Phosphorus is right here. 15 protons, so therefore 15 electrons. Okay, it happens to also coincidentally be in group number 15. So if it's in column number 15, it means it has 5 valence electrons. Okay, so let me ask you this. Is phosphorus more likely to accept 3 electrons to become a full octet, or is it going to donate its 5 valence electrons? Well, it's actually 5 is closer to getting full than getting closer to being empty. I mean, the halfway point is 4. You know, between 1 and 8, halfway point is 4. 5 is past the halfway point. We are closer to becoming 8. So it's more likely going to accept 3 electrons. So if it gains 3 electrons, it's going to get 3 more negatives. So phosphorus is, when it forms an ion, it forms a 3 negative ion. And if we check right here, there we go. See, phosphorus is could become P3 negative, which is called phosphide. Okay, last one, magnesium. Magnesium is right here. Magnesium has an atomic number of 12, therefore it's got 12 protons and it's got 12 electrons. It's in the second column, therefore it's got 2 valence electrons. And because it's in the halfway point of 8 valence electrons, does it have more than 4 or less than 4? It has less than 4. That means it's more likely going to lose the electrons. And remember, we talked about it. Whenever you lose electrons, losing a negative of a negative is a positive. When you lose negative, another negative becomes positive, and you lose 2 of them. So we double check our answer. Magnesium is right there. Okay, see, it says Mg2+. Now, this is like the long way, okay? This is not the shortcut. This is actually the long way. This explains how potassium, iodine, phosphorus, magnesium, how some are positives, some are cations, some are anions, negatives, how they all vary in valence electrons. This was the hard way. The shortcut is, ta-da, or this periodic table. It tells you how many valence electrons. Now, it even tells us the number of, I'm sorry, not valence electrons, the ions. It's a cation or an anion. It even tells you, like, for the transition metals. And sometimes there's multiple. If you look at, for example, iron is symbolized Fe. You could have iron Fe3+, which is, it lost 3 electrons. Or you can have iron Fe2+, where it lost 2 electrons. And because there's 2 different irons, we call this an iron 3 because it's got a 3 positive, and it is called iron, that's Roman numeral 2, iron 2 for Fe2. So if you ever see multiple, for example, for palladium, for nickel, for copper, that Roman numeral tells you. So copper 2 is copper 2+. Copper 1 is copper 1+. Okay? Now, usually this happens, actually not usually, always happens, when we have multiple ones when they're cations. Okay, that's what the periodic table is for. It's to help you. The ones that don't have a positive or negative charges are going to be these guys, the noble gases, because they're noble. They don't hook up with anyone. So neon will never be a positive or negative. Okay. Now there are others that don't have a charge. Look at boron, carbon, silicon. There's some that don't. It'll show you here. Okay. So we're going to use this one for our next handout. Okay. Actually, no, you know what? We're still in the practice problem. The practice problem has answers here. Okay. So I'm just going to show you right here. You could always try this out on your own and see and verify if you got the same answer. But I'm going to explain what's happening here. When we have something like potassium and iodine, okay, we already had it right here. Potassium is a 1+ charge. So potassium is K, and it's got a positive charge. And iodine is I, and it's got a negative charge. Now, whenever you have a positive and negative, first things first, the positive, the cation always comes first, and then the negative. Okay? You never write IK. Okay, that does not exist. The reason why, it's never iodine, potassium. It's always potassium iodine because positive comes first, negatives comes second. Now, what happens with ions is opposites attract. Positives are attracted to negatives. In this case, a positive 1 is attracted to, I'm sorry, one positive, not positive, one positive is attracted to a 1 negative. Well, that's it. You just bring them together. You bring the K together, you bring the I together, and you're done. Now, as a bonus, you could name it. And naming is very, very simple. Just bring this name, potassium. I'm going to write it in a pen because with Sharpie, whenever we're not a room, hopefully you could read that. Potassium. Now, potassium stays potassium. And you could even use this paper right here to show you that, where are you, potassium? K. Where's K? Sorry, I was looking at potassium. See how the K, it's still called potassium? Okay, that's always, you don't change the name, but you do change the name whenever whenever it's an anion, whenever there's a negative. So example, oxygen becomes oxide, fluorine becomes fluoride, chlorine becomes chloride. Okay, when it comes to iodine, see how it ends with I-N-E? It becomes iodide. So you could use this to look it up. So the proper way is iodide. That is the name of this chemical, potassium iodide. Okay, so we're not doing crisscross yet. All we're doing is bringing a positive and negative together. One positive and one negative come together. Everyone's happy. Okay, now let's do a similar one. Let's look at for calcium and let's look for oxygen. Using this right here, calcium is right here. Calcium is a 2+ charge, 2+. And when we look at oxygen, oxygen right here is 2 negative. 2 negative. Okay, that's simple as well. Positive comes first, negatives come next, and positives are attracted to negatives, and a 2 positive and a 2 negative, they cancel out. So basically, these get canceled out. We just bring them together. CaO. Now, as a bonus, you should learn how to name them because you will need to name them later on. Ca is calcium. That doesn't change. But O, it's not oxygen, okay? Because it was a 2 negative. And 2 negative is called oxide, okay? So, now you might be thinking, well, it's not negative now. Well, yeah, it's not negative now because the 2 negative got canceled out by 2 positive, but it was negative. This oxygen was actually oxide. So when you bring calcium, which is 2+, and oxide, which is 2 negative, you get calcium oxide. If this oxygen wasn't negative, they wouldn't have hooked up. Because in order for the oxygen to stick to the calcium, the oxygen had to have a 2 negative charge to go with the 2 positive charge. What's happening is calcium is going to lose 2 electrons. Remember, positive means you're losing electrons. Calcium is going to lose 2 electrons, and oxygen is going to gain them. Okay, that's how they come together. All right, now we're getting to the good part. How do we crisscross? I have to fold my paper because you can't see it. There's a little tripod here. That's why I have that camera hanging above me. Okay, we're going to do potassium again. Potassium is K. And oxygen. Now, going back from our notes, we could use this. We could also remind ourselves that potassium had a 1 positive charge. So I'm going to put here 1 positive, okay? And oxygen was a 2 negative charge. We could always use this to double check our work. Potassium had a 1+ charge. Oxygen had a 2 negative charge. Okay, so here's the problem. Yes, we have a positive and we have a negative, and opposites attract. The only problem is that we have here a 1 positive and this is a 2 negative. The numbers don't match. Okay, now one way we could have done this is we could have figured out where this is a shortcut. Where what if we added another potassium? See that? If we add another potassium, 1 positive and 1 positive becomes 2 positive. 2 positives and 2 negative cancel out. So our final answer is K2O. See? The 2, it's not on the top. Okay? The 2 is on the bottom. This 2 means I have 2 potassium. You guys have seen this before. You guys have seen this when, for example, when we write out H2O. That's like probably like the first chemical equation you ever learned. Probably knew about it first grade. But you probably didn't know what this is the 2 mean next to the H. H2O means that you have 2 H's and 1 O. H2O actually looks like that. 2 H's and 1 O. H2 and an O. That's what the 2 means. This is not positive or negative. The positive and negatives go up here. This is where you put your positive or you put your negative sign. The bottom, okay, this is called a subscript. It tells you how many did you need. You needed 2 H's and 1 O. So this number right here means that we use 2 potassium. Oops, see, there's the one I was telling you about. Let me fold it in. Okay, now this is actually a shortcut, but it's not the best shortcut. There is something called the crisscross method that makes it a lot easier. Basically what it says is this, okay, let's start all over on this paper. Let me get a blank paper. We had K, which is 1 plus, and we had O, which is 2 negative. Okay, now what the crisscross method is that whenever you're combining positive and negative ions, always put the positive first and negative second. We already talked about that. But what happens if the numbers don't match? You see earlier when we did potassium iodide, 1 positive and 1 negative, they matched. 1 positive, 1 negative, they cancel out. We get Ki. And when we had calcium oxide, the 2 positive and 2 negative, they canceled out. So we just got rid of them. But what happens when the numbers don't cancel out? What happens when one number is different than the other? Well, the crisscross method is this. You take this number and you bring it here in the bottom. You take this number and you bring it right here. Okay? Now, these cancel out. Now we can erase them. And notice that I brought down the number, but I didn't bring down the sign. The bottom, you don't put positive or negative. Okay, the ions, cations, anions go on the top. This just tells you the number. What you end up getting is K2O1. Or in other words, K2O. You don't have to write the 1. Okay, it's like, for example, you don't see H2O1, even though technically that's correct. H2O1 means 2 H's and an O, but you know that H2O is written as H2O, water. Notice that the 1 is kind of like invisible. Okay, you don't see it. A lot of this is very similar to algebra. Okay, when you were doing algebra, you talked about 3x plus 2y and blah, blah, blah. But what happens when you had something like b? Well, where's the number? I mean, you have 3x's, you have 2y, 2 y's. But when there's like a b, you knew that means 1b. There's a hidden number right there. 1 you don't have to write. Okay, so technically you don't have to write the 1 in H2O. The 1 is kind of like invisible. Same thing here. You don't have to write the 1, just K2O. And if we go back, that was our answer. Okay, we just have to crisscross. So let's do this right here. Magnesium. Let me show you how crisscross, how easy that works. Magnesium. Oh, you know what? Let me go back. We have to give it a name. This is potassium, and oxygen would be oxide. So potassium oxide. Okay, now you don't need to say dipotassium. You don't do that because even though there's 2 potassium, you just say potassium. Okay, because you needed 2 to balance out. So it wasn't by choice that you added 2. You were forced to add 2. So you don't have to put 2 in the name. Just potassium oxide. Bring the names together, but just change oxygen to oxide. Okay, so now we have magnesium. And magnesium, according to this, is right here. Magnesium is a 2+ charge. And chlorine, Cl, according to this, Cl is negative, chloride. 1 negative, okay? So what we have right here is basically, once again, we have a positive cation and a negative anion, but numbers don't match. crisscross method. We're going to circle the 2 and bring the 2 over here. We're going to cross it over. And we're going to circle the 1 and bring the 1 over here. Okay? Get rid of these. Notice I only brought down the number, not the positive or negative. Okay? All right, I'm going to rewrite this. Mg, I'm going to put the 1 for now, then Cl, and number 2. And I'm going to rewrite it. Remember, you don't need the 1. So it's Mg, Cl, 2. So whenever magnesium and chlorine hook up, you need 1 magnesium and 2 chlorine. And the name of this is magnesium, but not chlorine. Look over here. When it's negative, it's called chloride. So that is what happens when magnesium and chlorine come together. Magnesium chloride, it's 1 Mg and 2 Cls. Okay? So let me do a few of the problems. I'm only going to do one from the... Hold on, I got my papers all over. I'm only going to do one on this handout because I'm already pushing 30 minutes in the video. If you need more help or you want to go over more examples, I have my Zoom office hours on Tuesday and Thursday starting at 8:30, and there I could go over more problems. Okay, so let's do the first one, calcium and sulfur. So obviously it's going to be Ca and sulfur S. Okay, using my periodic table, calcium is right here. Calcium is a 2 plus. 2 plus. Sulfur is right here. 2 negative. Okay, do we crisscross? No. Why? Well, a 2 positive and a 2 negative already cancel each other out. You don't need to crisscross if the numbers match. 2 positive, 2 negative cancel out. So no need to crisscross. We just bring them together. We get CaS. And then the name, don't forget the name. I want the name to see this. I want to see calcium. And it's not sulfur. Remember, when it's anion, negative, it's a different name. It is sulfide. This is misspelled, by the way. Just notice it. S-U-L-F, 1-I-D-E. Okay? Double I? No, I don't think so. Okay? So there we go. Calcium sulfide. Okay. That one's pretty easy. That one didn't involve crisscross. So let me do one that it does involve crisscross. Let me see. I'm going to look at random and see. Boron. Let's see. Boron, this one, I believe, you know what? I think it's going to have a... According to this, there is no charge. But I think there, let me see, 5. You know what? Boron, it's going to have a 3 plus charge. Okay, you're going to need to know that one. I think that's another mistake. Boron's got a 3 plus charge, okay? So when you do this one, you're going to need that one. But let's skip. I want to see, we did already calcium, oxygen, sodium, Na, and... Okay, this one's good. Let's do the bottom one. So just know that for boron right here, boron, even though this one doesn't tell you the sign, for this one, it can be a 3 plus, okay? All right, so sodium. Sodium right here is Na plus, and it's a Na 1 plus, and a phosphorus is right here, phosphide, P3 negative. So P, oops, forgot, should have done this. No wonder it felt weird. It'll be a little bit easier. C. Okay, positives go first, negatives go second. Do the numbers match? No, they don't. 1 plus, 3 negative, 2 different numbers. So we're going to crisscross. We're going to bring the number, not the sign. We're going to bring the number here. 1. Bring this one here, 3, and then write it out. So we have Na3, P1, but that is actually not appropriate. The appropriate way would be Na3, P, okay? Because the 1 is invisible. Now we have to name it. The name is sodium phosphide. Okay, that's sodium phosphide. When you bring sodium, phosphorus together, you have to do that. Now, why? Just to review, why do we have to crisscross? Well, you're like, what is the point of crisscross? Why do we have to? Sodium was a 1+. Phosphide was 3 negative. Okay, so you need 3+ to hook up with a 3 negative. Well, we only have 1+, so let's bring in another sodium. 1+ and 1+ is 2+. Let's bring in another sodium. See? 1+, 1+, 1+. When we bring them together, that's 3 pluses. And we got our 3 negative. 3+ and 3 negative cancel each other out. So whenever sodium and phosphorus hook up, you actually need 1, 2, 3 sodium to do the job to hook up with 1 phosphorus. That's why crisscross is so useful. It's a shortcut where you just bring the numbers down and you get the same answer. I mean, would you rather do this or would you rather do this? Okay? Just know that crisscross does not work like in this problem when you have a 2 positive and 2 negative. The numbers match. Okay? So 2 positive will cancel out 2 negative. No crisscross necessary. Just erase it and bring these together. Okay? Now, honors, you guys have a bit of the same, but it's just a little bit more tedious. And you have this one. Now, this is also available to my regular science class, my 5th period class. If you want to do this one, this is more practice. Basically, what you're doing is like this grid. On this column, you have all of your positive cations, and on this row, you have your anions. Remember, positives go together with negatives. All you have to do is bring it together, and you could even do the crisscross in your head. You don't have to show the work. It's pretty simple, okay? Now, for part A, it says use the crisscross method to do that one, and you do. And right here it says part B, write the names of the compounds formed in the above table. Basically, if you've noticed, is that all of these positives and all these negatives are repeated down here. So you solve it here, but you write the name down here. Let me show you. NaCl, that's table salt, the salt that you put on your French fries. We're going to bring the Na and the Cl together. Now, Na is 1+, Cl is 1 negative. No crisscrosses, bring it together. NaCl. Okay? Now, the name of this is sodium. Not chlorine, it would be chloride. Okay, and if you need any help, you would just go over here. Na, sodium, Cl, chloride. There's the name. All right, now let's do a slightly more difficult one. Look at this one right here. Na plus CO3, 2 negative. For this one, I'm going to use a clean sheet of paper because I want to show you a little bit more in detail. So I'm putting together Na. 2 negative. Now, this is called a polyatomic ion because notice that you need several atoms. You need 1 carbon and 3 oxygen to get a 2 negative charge. Now, I don't know why they didn't do this, but whenever you have polyatomic ions, it's very common to put them in parentheses because that way the parentheses shows you that all of these are together and as a group, they combine form a 2 negative charge. And you're going to thank me later. You're going to need to put parentheses anyways because when you crisscross, I'm going to show you what happens if you don't put the parentheses when you crisscross. Okay, Na is +1. And actually should be 1+. My bad. Forgetting, number goes on the front. See, even I make mistakes. And then CO3 combined is a 2 negative charge, okay? I believe that's carbonate. All right, let's do a crisscross because 1+ and 2 negative don't match. I'm going to bring the 1 over here to the outside. I'm going to bring the 2 over here to the outside. So I'm going to rewrite this. Na2 parentheses CO3 1. I could rewrite it where I get rid of the 1, where I have here Na2 CO3 like that, without writing the 1. Now, I could write it without a parentheses. It's perfectly fine if I put Na2CO3. But let me show you what happens if you crisscross without parentheses. Okay? So let me show you a common mistake students make. So I have here Na, which is a 1 plus. I'm not going to make that mistake again. And then we have CO3, which is a 2 negative. Okay? Let's see what happens, what students sometimes do when they crisscross and they forget to put a parentheses. I'm going to bring this 2 over here. I'm going to bring this 1 over here. This is what students end up writing, Na2CO31. That escalated quickly. This 1 means that we have 1 of everything here. I don't have 31. You see the parentheses kind of like separated the subscripts. Whenever you see a polyatomic ion, in fact, I'm going to do it right here. I'm going to write it in parentheses for you. Okay? Even the OH. Notice that I'm putting the anion, the 3 negative, the 2 negative, I'm keeping it outside the parentheses. Okay? So for this one, the answer was Na2CO3. Now the name. We know the Na is sodium. It's easy. In fact, all of these will be sodium, 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 sodium. It'll go all the way across. But CO3 2 negative, I need to look that up. Yes, even I have to look it up because what's the point of memorizing stuff like that when you have these handy dandy charts? CO3 will be, no, that's Cl. There we go. Yeah, I was right. Okay, carbonate. Look at that. So CO3 2 negative is carbonate. So this is sodium carbonate. This is why you need this paper. This was on the back of this right here. And I believe carbonate also shows up right here. I don't see it. Yeah, oh, there it is. There's carbonate. So if you can't find it here, your polyatomic ions, and you're going to need it for the name, then look in the back as well. Here are some more, okay? Let's do for fun 1 more. And let's do, in fact, we'll do 2 more right here. When crisscross works and doesn't work. Let's look at calcium right here, Ca2 plus, and let's do the carbonate one, okay? So the name is already easy. Calcium and carbonate. In fact, you're going to see a pattern that this one, Ca2 plus, this will be calcium, that'll be calcium, first name calcium, first name calcium, first name calcium. And then this is carbonate. So the last name, it's like first name, last name. It'll be sodium carbonate. Okay, this would be potassium carbonate, calcium carbonate. NH4, I looked that up, that's ammonium. So that would be ammonium carbonate. So once you start the name like sodium, 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 like that, and you could go all the way across, and then when you go down, that'll be remember the anion, the negative comes second. So it'll be like the last name, the second name, sodium carbonate, calcium carbonate. I mean, you could just fill out 1 row here, 1 column, and then you could get all the columns after that. It's going to be easy peasy. But let's do this one, calcium and carbonate. Now notice this is a +2, and this is or 2 plus, and this is a 2 negative. No crisscross at all. So I'm just going to bring them together. I'm going to bring here Ca, and I'm going to bring this guy CO3. Notice that all I did is, just, I don't have to bring the signs. A 2 positive and a 2 negative cancel out. So just bring them together. That was easy. But what about this one right here? PO4 3 negative. PO4 3 negative. I'm trying to see if I can find it. That's phosphate. Okay, so let me get a blank paper. This will be the last one. In fact, we can even name it right here. Calcium. And when I looked it up here, PO4 3 negative is phosphate. So the last name would be phosphate. So that means that all of these would be phosphate. This would be, for example, sodium phosphate. See how easy it is to name? It's called nomenclature when you're naming chemicals. Okay, So right now we're doing calcium phosphate. Calcium is Ca 2 plus, phosphate parentheses PO4 3 negative. Okay. Now we already set it up. Positives comes first, negatives come second. Okay. We're gonna bring this cation anion together. Now the problem is two positive and 3 negative, they don't match. We have to crisscross. I'm going to bring the 2 over here. I'm going to bring the 3 over here. So now I'm going to rewrite it, but without these positive or negatives. It's going to be Ca3 parentheses PO4 2. So that means that whenever you combine calcium and phosphate, you need 3 parts calcium and 2 parts phosphate. It's kind of like you're baking a cake. You need 3 eggs and you need 2 cups of flour. We need to know the exact amount of ingredients. In order for these to come together, we need 3 parts calcium, 2 parts of this phosphate. Okay, so that's your answer, and I'm going to write it right here. Ca3 PO4 2. Now, after a while, you're going to be able to do mental math. You're not going to need to do this. You're going to look at the positive and negative and be able to do the crisscross in your head and figure, oh, Ca2 plus, I'm going to put 2 here, and a PO4 3 negative, I'm going to put the 3 here, and then I'm not going to put any symbols. Okay, there is no backside, by the way. There's just the front, but it's 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's 66 problems that you're doing right here. Okay, worksheets are due Sunday at 11:59, so you have plenty of time to do it. I will be doing my Zoom office hours on Tuesday and Thursday, where we will go over other problems. I'm going to hold on to this one, so that way if you have a question, I don't want people asking me, well, how do you do this one? We already did it in the video. Show me another one and I can help you in the video. If you missed Tuesday's Zoom meeting, I have a meeting on Thursday as well. Okay, that's it. Take care, stay indoors, stay safe, and I'll see you at the Zoom meetings. Bye.